Hello, my name is Aubrey Terleski, and this is my presentation on bone growth, which is also known as ossification, and it's the process where bone tissue replaces cartilage or other tissue, forming the hard, mineralized structure of the skeleton. And specifically, we'll be covering the different types of bone growth, as well as explaining which bones each type of bone growth occurs in, the layers of the bone and their functions, discussing the cells involved and their roles, as well as how bone growth supports development, healing, and maintenance. Okay, so there are two types of bone growth, which are longitudinal growth and appositional growth. Longitudinal growth is the first growth we're going to be covering, which is how bones become longer, and this mainly takes place in the epiphyseal plates, which is also known as the growth plate, and it's a layer of hyaline cartilage located near the ends of long bones in growing children and adolescents. This allows the bone to grow longer until adulthood, when it hardens and then the growth stops. So this takes place in a three-step process where the chondrocytes in the epiphyseal plate divide and grow, and this pushes the epiphysis, which is the end of the bone, away from the diaphysis, which is the shaft of the bone. The older chondrocytes get bigger and signal the bone to harden, and this is called calcification. The osteoblasts then invade this area and replace cartilage with new bone tissue. Osteoblasts are bone-building cells, and this process continues until the epiphyseal plate completely ossifies, which means it turns into bone. This usually happens by late teens or early 20s, and the longitudinal growth stops at this point because there is no more cartilage left to turn into bone. Okay, so the second type of growth is appositional growth, which is how bones increase in thickness or diameter, and this occurs on the outer surface of the bone, also known as the periosteum. This is a tough fibrous membrane that covers the outer surface of bones, and this is a two-step process known as mottling. This is where cells called osteoblasts, located in the periosteum, secrete new bone matrix on the external surface. At the same time, osteoclasts on the inner surface of the bone, endosteum, break down bone tissue. This widens the medullary cavity, the hollow space inside the bone, preventing the bone from becoming too dense and heavy as it increases in diameter. So now this brings us to the types of bones that each type of growth occurs in. Longitudinal growth usually is found in long bones, like those in your limbs, such as your femur, tibia, humerus, radius, and ulna. And appositional growth occurs in all types of bones, long, short, flat, which would be skull, and these flat bones typically grow through intramembranous ossification, and this appositional growth also occurs in irregular and sesamoid. Now we are going to talk about the layers of the bone. The first layer is the periosteum, which is the outer layer, and it protects the bone and provides attachment points for tendons and ligaments. This is composed of two main layers, the outer fibrous layer, which is made of dense connective tissue and provides protection and support, as well as the inner osteogenic layer, which contains cells like osteoblasts and osteoclasts that are important for bone growth, repair, and remodeling. The compact bone is next, which provides strength and protection to the bone, weight reduction, and flexibility. This is composed of osteons, the central canal, osteocytes, and canaliculi. Spongy bone, also known as cancellous bone, provides support and reduces weight, contains red blood marrow, and blood cell production. This is composed of tuberculae, which are irregularly arranged lamellae and osteocytes. It also has a matrix, which is similar to compact bone, as it is made of calcium phosphate and collagen fibers, red bone marrow, and yellow bone marrow, which are the fat cells. The next layer is the endosteum, which participates in bone remodeling and growth. This is composed of a single layer of osteoprogenitor sites, osteoblasts, and osteoclasts, and it has connective tissue as well. The bone marrow is the last layer, which produces blood cells and stores fat. These are composed of red bone marrow, which is hematopoietic stem cells, blood cells, and supporting cells, and it also composed of yellow bone marrow, which are adipocytes, which are fat cells. I just wanted to quickly talk about the spongy bone because this is only located at the ends of long bones within the anterior vertebrae and in flat bones like the pelvis, ribs, and skull. Okay, so the main cells involved are osteoclasts, which are for bone resorption, and they are also known as the breaking cells. These are large multinucleated cells that resorb bone tissue. They secrete acids and enzymes that dissolve the bone matrix, releasing calcium and other minerals into the bloodstream. Osteoblasts are bone-forming cells that synthesize and secrete the organic components of the bone matrix, known as collagen and other proteins, and they also initiate the calcification of the matrix. Osteocytes maintain the bone matrix. These are mature bone cells embedded in the bone matrix, and they maintain the bone tissue by exchanging nutrients and waste products with the blood. They also play a role in sensing mechanical stress and signaling to osteoblasts and osteoclasts to remodel the bone. So now we're going to talk about the three main things that the bone growth supports, which is development, healing, and maintenance. The first we are going to talk about is development, and this is mainly through two processes, longitudinal growth and intramembranous ossification. Longitudinal growth is responsible for the formation of long bones. And this begins with the cartilage model that is gradually replaced by bone tissue. Chondrocytes proliferate and hypertrophy, creating a framework that is then invaded by osteoblasts. These osteoblasts then deposit bone matrix, leading to the ossification of the cartilage model. Intramembranous ossification is responsible for the formation of flat bones, such as those in the skull. This is where osteoblasts differentiate directly from the mesenchymal cells, which are the embryonic connective tissue, and begin secreting bone matrix at ossification centers. This is where the bone matrix calcifies and the osteoblasts become trapped within the matrix, transforming into osteocytes. Now we're going to be talking about the second process that bone growth supports, which is healing, and this can be done through a variety of things. Hematoma formation is one, which is where a bone fractures and then the blood vessels rupture, forming a hematoma, also known as a blood clot, at the fracture site. Fibrocartilaginous callus formation is where fibroblasts and chondroblasts migrate to the fracture site and begin producing collagen and cartilage. This forms a fibrocartilaginous callus that bridges the broken ends of the bone. Bony callus formation is also a process of healing where osteoblasts replace the fibrocartilage with spongy bone, forming a bony callus. Bone remodeling is where osteoclasts remodel the bony callus, removing excess bone tissue and restoring the original shape and structure of the bone. The last thing we will be covering in this presentation is the maintenance, and this is done through two things, bone remodeling and mineral homeostasis. Bone remodeling is a continuous process involving the coordinated activity of osteoblasts and osteoclasts. This allows the bone to adapt to changes in mechanical stress, repair microdamage, and maintain mineral homeostasis. Mineral homeostasis is where bones serve as a reservoir for calcium and phosphate, which are essential for various physiological processes. This helps regulate the levels of the minerals in the bloodstream by releasing them from bone tissue or depositing them back into bone tissue as needed. In summary, bone growth supports development by forming the skeleton, healing by repairing fractures, and maintenance by continuously remodeling bone tissue and regulating mineral homeostasis. This brings us to the end of this presentation, and these are just a few of my references. Thank you so much for listening to this, and I hope you all enjoy.